Welcome to Magic Academy. We are going to apply all we have learned about valency of elements and the radical. We are going to apply it now to write the correct formula of compounds. But don't forget that the radicals we learned, like that one CO3. Remember why it is a radical? It's made up of carbon and the three molecules of oxygen, or three atoms of oxygen. So only this one is called triosocarbonate 4. CO3 is triosocarbonate 4. Then NH4 is ammonium. So ammonium. I know why I'm repeating all these things. Now SO4 is tetraososulfate 6. Tetraososulfate 6. Don't forget that all of them are radicals. They are numerous. This one is a triosonitrate 5. Just for you to know their names. Remember, they have their respective valencies. Now, assuming that you are told to write the formula of sodium tetraososulfate 6. So, sodium tetraososulfate 6. Everyone here knows that sodium is Na, that is symbol. And its valency is 1, or its oxidation number is +1. Now, tetraososulfate 6, having known that this one is tetraososulfate 6, which is a SO4, its valency is what? 2. Remember what I told you? Valency is the combining power of an element. So they are going to exchange their valency. Sodium will take the valency of tetraososulfate 6, while that of this one will take the valency of sodium. If you write it correctly, you will see that the formula is something like this. Remember, 1 is insignificant here, because if you put 1 bracket 1 here, it still means the same thing. So this is the formula of sodium tetraososulfate 6. But just come back to this place now. Why is this one trioso? Because oxygen are 3 in number, and the prefix for 3 is tri. Why is it tetraoso here? Because the oxygen is how many? 4. Why is this one trioso? Just as we have previously. Don't forget that all these numbers written in Roman figures are not by accident. They are the mere oxidation state of that element closest to oxygen. Like when we will now start doing oxidation number, we're going to find oxidation number of a carbon. That is actually what makes it 4. And this one is what? 6. And so on and so forth. So we have written successfully the formula of sodium tetraososulfate 6. Again, let's check example 2. Let's check the other examples. This one is saying aluminium oxide. Example 2, aluminium oxide. The symbol for aluminium is Al. Oxide or oxygen is still O. Remember, when oxygen is standing alone, you can call it oxygen, but when it is combining with something else, the name will change from oxygen to oxide. But when it is forming, when it is acting as a radical, that is where you see tetraoso, triazo. So aluminium oxide, the valency of aluminium is 3. The valency of oxygen is 2. Don't forget, we learned this thing previously, how we get their valencies, respective valencies. If you missed it out, check the video there in the channel. Okay, so if you watch that very well, you see that they will exchange their valency. Don't forget aluminium oxide. This one will take the valency of this one will take the valency of this one. So the formula becomes Al2O3. This is the correct formula of aluminium oxide. Don't forget aluminium oxide. The other example, example 3 there is sodium oxide. Sodium, I'm talking about this one. Sodium is Na, the valency is 1. Oxygen is O, the valency is 2. So they are going to exchange their valencies. This one will take the valency of this one, and so on. So sodium takes 2 and oxygen takes 1. Like I have told you, 1 here is insignificant. So this is the correct formula of sodium oxide. Sodium oxide. Sometimes you'll be imagining, how are you putting 2? Where did you get the 2 from? It is actually from the valency of oxygen. They must exchange their valency in order to write the correct formula well. Okay, calcium hydroxide. Calcium hydroxide. We are dealing with this one. Calcium is Ca, the valency is 2. Hydroxide is a radical. Hydroxide is a radical. OH is a radical. And the valency is what? 1. So they are going to exchange their valency. This one is the valency of this one, and so on. So what we are doing here, calcium is taking 1, hydroxide is taking 2. So just think, how are you going to put that 2? Are you going to put that 2 here? If you put that 2 here, it will look as if the 2 is only affecting hydrogen, but it's supposed to affect both oxygen and hydrogen. So we are going to put a bracket and add that 2. So the formula now becomes CaOH in brackets. Watch it very clearly. If you put that 2 there, it will look as if it's only hydrogen. So the best thing to do is to put it in brackets. Let's check the other one. Ammonium tetraoxosulfate 6. Ammonium is NH4. Ammonium, example 5, is NH4. Now, tetraoxosulfate 6 is XO4. Valency of this one is 1. Valency of this one is what? 2. Just mind how I'm doing it. Tetraoxosulfate 6 is SO4. Ammonium is NH4. So they are going to exchange their valencies. Ammonia will take this one. Sulfate 6 will take this one. So the thing becomes NH4. Remember, it's supposed to take 2. What do? You use your brain, you put it inside bracket and put that 2. Sulfate is taking 1, SO4. So this is the formula of ammonium tetraoxosulfate 6. That is the formula. Let's check the other example. Copper 2 oxide. Copper 2 oxide. We are taking this one. Copper 2 oxide. Copper is Cu. The valence there, copper 2, which means copper has that 2 there. Oxygen is what? 2. So copper 2 oxide. Remember, copper 2, which means it is this copper that has the valency of these 2. Oxygen has the normal 2 as usual. They are exchanging their valency now. It becomes C2O2. And they have a common denominator. So the formula becomes this. This is the formula for copper 2 oxide. Copper 2 oxide. Now, copper 1 oxide, the last example there. Copper 1, Cu is the symbol for copper. Copper 1, which means copper has that 1. Copper 1 is the valency of this copper. Oxygen is 2, the normal 2 oxygen has. So when they exchange their valency now, copper will now take 2, oxygen will now take 1. Remember, it's the same thing as this. So this is copper 1 oxide, and this is copper 2 oxide. Sometimes when you look at it now, it says, what do you mean? This one's supposed to be copper 1, and this one's supposed to be copper 2. Because copper has these 2 here. It is not how it is done. It is not how it is done. Remember what we did? Copper 2 oxide, copper has the valency of 2. Oxygen, the normal 2, it has. So it becomes like this. Now, copper 1, copper has 1 here. Also here, when they send their valency, this is what you get.